So a baseball rolls off a 70 centimeter desk and strikes the floor 250 millimeters from the desk. How fast was it initially moving? Oops. So here's our baseball. It's on a table. Baseball is moving horizontally. Notice it can't go through the desk. So what that means is when it first goes off the desk, velocity in the y direction, Vyi, would have to be 0 meters per second. We know that because it can't go through the desk. We also know the height of the desk. Tells us it's 70 centimeters, so I'm going to convert that, 0.7 meters. So our y, since it's going vertical, is going to be 0.7 meters. Notice the ball is actually going to be going down. So the height is 0.7 meters, but since it starts up and it goes down, it's going to be negative 0.7 meters for the direction the ball is going. And then also, it tells us that it hits 250 millimeters away, so that is 0.25 meters. It's going horizontal, so that's our x. Since the ball starts at 0 in the y direction for its velocity, it's not going to just keep going straight forever. It's actually going to be accelerated down. And in the y direction, acceleration is almost always gravity. So it's negative 9.81 meters per second squared. I just put a sub y, acceleration in the y direction. Our unknowns. Notice how we do not have time. And it's asking for velocity. It's always a good idea to always solve for time when you're not given it. Usually if you get stuck, always solve for time. So it's asking for the initial. Since we said Vyi is 0, it must be asking for Vx. It could be Vxi if you wanted, but remember Vx never changes, so initial is the same as the final for Vx. We won't be able to do an equation with this, and so what that means is we're going to have to solve for something else, which we're going to choose time. We can solve for time, and then we'll be able to solve for Vx. So we're going to solve for time and then Vx. So our equation for time, the reason why you can use this equation is because Vyi is 0. The equation is y equals Vit plus 1/2 at squared. Because Vyi is 0, and this is all talking about the y direction. So this is the y direction, velocity initial in the y direction, acceleration in the y direction. And because this is 0, this cancels out. So we'll be left with y equals 1/2 at squared. Now we can sort it to solve for t. So we're going to divide first and then square root. So y divided by 1/2 a, square root it, will give us t. So we'll have 0.7 meters divided by 1/2, negative 9.81 meters per second squared. And this will give us t, which you should get a value of 0.378 seconds. Now we have time. So now we have time. We can solve for Vx. We have velocity, we have time, and we have x. So I'm just going to do velocity equals x over t. We can do that because this is velocity in the x direction, and that's just the time it took to hit the ground. So we have Vx equals x over t. You don't have to sort it, so I'm just going to do Vx equals 0.25 meters divided by 0.378 seconds. We will get a value for Vx to be 0.66 meters per second.